Example 9, finding the domain of a composite function involving radicals. We want to find a domain of f composite g of x, where f of x is equal to the square root of x plus 2, and g of x is equal to the square root of 3 minus x. Now, because we cannot take the square root of a negative number, the domain of g is negative infinity to 3. So now we're going to check. Okay, if we have f composite g of x, the definition means that we have f of g of x. Okay, now g of x represents what we define here. G of x is equal to the square root of 3 minus x. So we're going to replace g of x to be the square root of 3 minus x. And then we're going to plug this in to the function f of x. So what's going to happen is that we have the square root, and so this x is now going to become the square root of 3 minus x plus 2. Okay, so now in step 2, what we want to do is we need to look at this radicand that's under the radical sign. And so we need to look at this 3 minus x, and we know that regardless, whatever is under the radical sign has to be greater than or equal to 0, because we cannot take the square root of a negative number. We can take the square root of 0, which is the reason why it's greater than or equal to 0. Now 3 minus x is greater than or equal to 0. By solving for x, we subtract 3 to both sides, and then we divide by negative 1, which means we need to flip the inequality, and therefore we get x, which is less than or equal to 3. So what we want to do now is then graph this. When we graph this, we can see that we have a bracket at 3 and it's going towards negative infinity. So we get parentheses, negative infinity, comma 3 with the bracket. And therefore, that's going to be the domain of this composite function, because we need to find out what happens here to add the 2 and then take the square root of that particular number. Now, this example shows that knowledge of the range of functions, specifically the inner function, can also be helpful in finding the domain of a composite function. It also shows that the domain of f composite g can contain values that are not in the domain of f, though they must be in a domain of g.